an example of how to use present and future values to decide on investment. Here is the statement of the problem. You should pause the video and look at it, but I'll explain it. You have two possible investments for a period T of 5 years at an annual rate of 5%. Okay, so investment 1 gives you per year this amount written here, which is 3,000 e to the 0.03 t. But in order to invest here, it's a bank product or something like that, you have to pay $1,000. The second investment gives you $4,000 per year, which you invest continuously, and it costs you $3,000 you have to pay. Which one is better? To decide on that, because the investment are given different money over the years, what we have to do is some kind of a uniform way of value these investments. And for that, we can use either the future value, how much we'll get later, or we can use the present value. In this case, it's easier to use the present value. So for investment 1, we'll compute its present value 1, which is the amount you have to invest at once now to get as much as that investment. And for investment 2, we'll compute the present value 2, which is the same thing, the amount we have to invest now. And of course, the one that is bigger is the one that is better for us, because it's like we had that much amount to invest. Okay, so let's see. First, present value 1. Okay, we'll have to do a little bit here, but anyway, let's go for it. First, present value 1 is equals to the integral. Remember, the present value of an investment is the integral between 0 and the total time of the investment stream e to the minus the rate times t dt. In this case, become the integral from 0 to 5 of 3,000 e to the 0.03 t. Sorry, it's not clear. This is 0.03 t, because this is nothing but f1 written up there, e to the minus 0.05 t dt, and that becomes 3,000 integral from 0 to 5 or e to the minus 0.02 t dt equals to 3,000 e to the minus 0.02 t over minus 0.02 between 0 and 5, and you do this computation is 3,000, I'll do it only once, e to the minus 0.1, this is 0.02 times 5, minus when t is 0, this is 1, divided by minus 0.02. Let me reverse the order on the numerator and remove the sign in the denominator, and this becomes approximately, because it's an exponential, 14,274.39. That's the money you have now. If you have to get the money right now, suddenly that's how much you would have. Okay, for the present value 2, which is the integral from 0 to 5 of 4,000, this is the function e to the minus 0.05 t, that's the rate dt, and a computation gives you 17,695.94. So case 1 is that investment is like you have now 14,274.39, but to join this you have to pay 1,000 euros is the fee, $1,000 fee. So this is the amount that you will have right now. If you invest in this, it will give you in the future, but it's equivalent to 14,000 now minus 1,000 you pay to the bank is equivalent to having 13,000 now. The second case, you would have now is equivalent, the investment over 5 years is equivalent to have right now 17,695.94 minus the fee you have to pay. If you go up there, you see the fee is 3,000. So the difference is 14,695.94. So this is the amount you would have now. If you invested in the first one, this is the amount you would have if you invested in the second one. So obviously this is a better investment.